3I Atlas just flew past our sun. And this close encounter has revealed something new about our interstellar visitor, deepening the mystery of its true nature. If this object is a comet, it continues to be the strangest comet we have ever seen. And if it is something else, the world is about to find out, because 3I Atlas is our next target. It's a curious coincidence that this interstellar object arrives at this exact time in 2025, because this year marks a time when the sun reaches its maximum activity. We call this period solar maximum. And it only happens once every 11 years. During this maximum, the sun's surface is roiled by giant storms that produce solar flares and coronal mass ejections, which are essentially large chunks of the sun's atmosphere being blasted into space. Many of these solar storms will hit Earth, which is why people around the world have been seeing brighter, more vibrant auroras in the northern sky. Throughout 2025, those are bits of the sun reflecting off our atmosphere. Our solar maximum started in October 2024 and usually lasts about a year. So we're just past the peak, and that's where 3I Atlas comes in. For any comet, interstellar or not, the most dramatic moment in its life occurs when it passes close to a star. This perihelion phase is when the comet's distance from the sun is at its shortest, subjecting it to a flurry of energy, including heat, radiation, and violent coronal mass ejections. The same charged particles that create Earth's brilliant auroras also repeatedly collide with 3I Atlas, leading scientists to wonder if the interactions could reveal something unusual about the origins of this mysterious interstellar visitor. Before entering this phase, 3I Atlas was nearly impossible to observe because it was so far away. Earlier this week, NASA released the highest resolution image ever of 3I Atlas taken from a satellite orbiting Mars, just when the comet was closer to a planet than at any other time in its journey through space. The discovery raises hopes that we'll get the first data that will help decipher the true nature of this interstellar object, and may even open up new conspiracy theory-tinged questions that researchers have been quietly pursuing. But as you can see, what appears is just a faint blip of light hovering in the cosmic darkness. Not impressive, not dramatic, and not revealing any big secrets. For now, but don't despair. As 3I Atlas continues its descent toward the sun, events are about to unfold that could shake everything we know, and you'll want to keep your eyes peeled for what happens next in the next few minutes. Stay tuned, because what happens next will blow your mind if you are fascinated by the mystery of Atlas 3. I want to see more amazing cosmic stories. Hit that like button and let the universe know you are following. Every click helps keep the quest for the unknown going. Comment below and let me know where you are watching from. I want to see where in the world is witnessing this with me. You may have heard that Comet 3I Atlas is invisible when it passes close to the sun, simply because Earth is on the opposite side of the solar system at the time of observation. This is generally true, but there are rare and interesting exceptions. 2 solar observing satellites, equipped with special telescopes designed to peer directly into the brightest part of the central star, have opened a window that allows humans to still track the interstellar visitor's journey, even when it is bathed in the sun's intense radiation. The way it works is incredibly simple. By placing a small disk in the middle of the field of view to cover the entire surface of the sun, the brightest light is removed, revealing the sun's thin, but turbulent outer atmosphere. Thanks to this technique, scientists can monitor solar weather, identify magnetic storms, coronal mass ejections, and observe other objects that are otherwise obscured by the glare. Some recent studies have even suggested that the corona may harbor previously unrecorded physical phenomena, making astronomers even more curious about strange celestial bodies like 3I Atlas. Thanks to the coronagraph instruments on the US GOES spacecraft and the European SOHO satellite, we can still closely monitor the changes. 3I Atlas undergoes as it approaches perihelion. Every frame these systems capture could be a key clue from unusual signs as the comet encounters the radiation-filled environment around the sun, to unexplained changes that open up new questions about the origin and structure of this interstellar visitor as it approached the sun. 3. I-Atlas stunned the observational community. It flared up almost immediately. It's normal for a comet to increase in brightness as it nears a star, but 3I Atlas broke all known patterns. Instead of gradually increasing in brightness, it jumped to a brightness of about 400 times brighter in just a few days, an increase never seen before in any comet. Normally, comets only increase in brightness by 10 to 100 times as they approach the sun, depending on how much ice is heated and vaporized in the harsh environment of the solar corona. But 3I Atlas far exceeded all predictions. This unreasonable increase in brightness has many scientists puzzled and raised new questions about its true nature. Is it simply the result of a structure rich in volatile materials, or is it revealing the existence of compounds previously unknown in solar system comets? While scientists were still analyzing the data, fringe theories and conspiracy theories began to flourish. Some suggested that 3I Atlas might contain unnatural materials or be affected by some strange energy mechanism that was not yet understood. Some even speculated that the sudden flare was the result of the comet reflecting a strange signal from the interstellar medium, a signal that was not yet detectable by current human instruments. These bold hypotheses, despite the lack of evidence, only made 3I Atlas more mysterious and intriguing to the public. And if this is just the beginning of its perihelion journey, the events that follow could be even more surprising. 3. I-Atlas not only flares up unusually bright, but it also surprises observers with its constant color change, a phenomenon that defies the usual rules of comets. When observed in the summer, its reflected light is heavily tilted toward the red end of the spectrum. This does not mean it appears red to the naked eye, but simply means that most of the reflected light is concentrated in the red range, which is completely normal for a comet that contains a lot of gas and dust. But that normalcy didn't last. In early September, 3, I-Atlas suddenly turned green, a green tint so intense and sudden that no previous literature could fully explain it. Green hues in comets are sometimes associated with the decay of diatomic carbon C2. But in 3 I-Atlas, the intensity was too great and too unusual to be considered a familiar phenomenon. And as it got closer to the sun, the comet changed color again from green to blue. This was a complete reversal of what physical models predicted. Normally, as ice evaporates and dust clouds thicken, the reflected light tends to shift toward the red, but 3I Atlas seemed to ignore all the rules, shifting deep into the short wavelength region, something no traditional spectral model could adequately explain. This unusual discoloration has led some researchers to suggest cautious hypotheses as three. Atlas revealing traces of previously unknown compounds, or does its structure contain materials completely foreign to the environment of the solar system? More extreme conspiracy theory suggests that it could be the reaction of an alien substance, or traces of ancient technology from interstellar space, a science fiction idea that adds to the story's appeal. Of course, science still needs more data to draw conclusions, but it is this inexplicable weirdness that makes 3I Atlas one of the most unpredictable, mysterious, and fascinating celestial bodies in the entire history of human observation. When we put 3I Atlas's strange burst of brightness alongside its previously unrecorded color changes, we're left with a few plausible natural explanations. The first possibility is that the comet suddenly released a giant cloud of gas that glowed intensely in the blue spectrum. What's puzzling researchers is that we don't know what kind of gas it was, or why it glowed so brightly. Comets ejecting gas is common, but emitting such a large amount of gas with such intense blue emission is clearly unlike anything else observed in other comets. Still, it could theoretically be natural. The second explanation is a more common scenario disintegration. Many comets are broken up by the sun as they enter its intense heat and gravity, causing them to break into smaller pieces. The sudden increase in brightness or color change can sometimes be related to that process. However, this hypothesis was ruled out almost immediately when we observed that 3I Atlas remained largely the same after passing perihelion. There was no fragmentation, no fragments breaking off, and no sign of disintegration at all, which leads to the bigger question, what actually happened at this point? Only a third hypothesis remains for those brave enough to face the most unlikely possibility. If there is anything that 3I Atlas has shown that suggests some form of unnatural propulsion technology from an extraterrestrial civilization, it is this phenomenon. Because the sun's energy, chaotic and enormous as it is not enough to produce such a profound and uniform change on its own. The change in color and brightness seems to originate from within the comet, as if it possesses some kind of internal force operating independently of its surroundings. Of course, it could also just be some unknown gas escaping through a mechanism that current science cannot describe. But if we choose this simple explanation, we are faced with a much larger question: what will 3I Atlas do next? And the answer, as it turns out, is more worrying than just emitting a cloud of incomprehensible gas. Immediately after that bright blue flash, something even stranger happened. 3I Atlas's orbit actually changed. As it hurtled toward perihelion in the sun's massive gravitational field, it suddenly underwent a sudden acceleration that defied any known gravitational models. The data suggested that 3I Atlas was generating its own thrust, and the acceleration was so rapid that the teams had to constantly update their predictions just to stay ahead. Normally, the violent evaporation of comets near the sun can create small thrusts that slightly shift the orbit, an effect that has been observed many times, but 3I Atlas showed an unusually large deflection, seemingly self-correcting, like an object being driven by some internal force, rather than simply drifting along the laws of nature. Add in the intense flares, the strange color changes, the mysterious blue rays, and the changing orbit, and many experts are starting to question whether this is even a comet at all. Some conspiracy theorists are more outspoken, suggesting that 3I Atlas may be using some unexplained unnatural mechanism. During its journey into the solar system, we detected almost no anti-gravitational acceleration on 3I Atlas. It had a remarkably stable orbit, much less wobbly than typical comets, which are constantly jolted by jets of material ejected from their cores. This stability made 3I Atlas an exception from the start. But at perihelion, it experienced unprecedented microgravity acceleration. On October 29, at its closest approach to the Sun, it was observed to drift about 135 kilometers from its predicted position and accelerate 60 kilometers faster than its modeled velocity. In total, it experienced about 200 kilometers of microgravity acceleration per day, a rate that is far above the norm. To put that in perspective, 2I Borisov, the only other well-studied interstellar object, generates only about 100 kilometers of NGA per day, less than half of 3. I Atlas, Hale-Bopp, one of the most powerful comets ever observed, produces only 1% of 3. I Atlas's NGA. This means that under the influence of the Sun, 3I Atlas is not only